Hi guys, this is Vikas Reddy from SVC Bengaluru. Today I am here to present about seminar presentation on wireless optical communication network based on ant colony algorithm. And these are the contents which we are going to explore now. Introduction, literature survey, objectives, applications, results, conclusion, references. Introduction. Wireless optical communication networks have gained increasing attention in recent years due to high data rate, low power consumption, and low interfaces. The design of wireless optical communication is challenging due to complex and dynamic nature of wireless channels. Once processing approaching designing wireless optical network will be nature inspired through the ant colony optimization. Ant colony optimization is inspired by behavior of ant colonies searching for food. How they are searching from food surroundings to that ant colonies. By that, we are creating one artificial ants to search for the optical solutions throughout the surroundings. The algorithm works by creating pheromone trails that guidance by the ants search for food. The trials is updated based on quality of solution founded by the ants, and the algorithm is mainly gives iteratives, and trials is updated by each and every iteration. Wireless optical communication networks are proposing technologically for high speed high bandwidth communications in saturations where traditionally wired networks are impossible. Through wired networks, we can't provide high speed, high bandwidth, and colony optimization of designing through wireless optical communication. The addressing challenges posed by the complex and dynamic nature for wireless channel. The multiple hopes architecture has much shorter wireless, smaller transmission power, and node interfaces. These are the literature review which I referred from some of those papers. In first paper, they were adaptive coded modulation for IM or DD, free space optical blinking a possibility shaping approach. In this paper, the pros will be it can provide a solution to satellite communication system to achieve higher spectral efficiency and also a rate close to the low boundary on the capacity of FSO channel. FSO nothing but a free space optical communication. If the communication between two endpoints will be low means this paper will be the solution will be very strong from one satellite to other satellite. Um, in con will be partial adaptive modulation scheme to approach for free space optical channel with the direct detection by shaping. In the second paper, uh, improving small satellite communications and tracking in deep space, reviewing by existing systems and technologies with recommended for improvement. And in part two, small satellite navigation, programming skills, and communication link science. The in this they used the method was small satellite direction to direct to earth. Communication between small satellite will be direct communication to earth, and navigation, these are all come from the satellites only. And con will be communication link relates to delay and disturbance enhancement to spacecraft. Anthony. In third paper, wavelength division multiple access for deep space optical communication. High data rate optical communicate proofs will be high data rate optical communication with two-dimensional architecture they used. In this, a higher number of bit per transmission will be happen in this wavelength division. Con will be the hard division optical receiving with counting detector. It will be some of the hard to detect those things. In the fourth paper, optimizing networked flying platform development and access points association in free space optimal communication based on networks. In FSO, communication has a deep demonstrated to achieve a higher data rate, longer transmission range, and less interfaces between two endpoints. Access point problem is the contents in this FSO based on relay networks. These are the objects which we are going to discuss now. To achieve the higher data rates by using AND colony optimization. Through other bandwidth and FSOs, we can't achieve that higher data rates. Through only an AND colony optimization only, we can get high data rates. To design a wireless optical communication network involves complex traits such as maximum power allowed and to minimize the power consumption of the link. We are giving maximum power to them, but we are using a minimum to consumption to we are using minimum consumption of link to finding the optimal link design using ant colony optimization enhances the overall performance of a wireless optical communication network. Now we are going to the working process. In this working process, we are divided two parts. One is the deep space optical communication and another is algorithm. In this deep space optical network consists of set of stability relay nodes which are from one end to another end or one satellite to another satellite. Uh, it can be helpful for higher ability capability. It provides a data links between a longer distance communication through one satellite to another satellite. The relay nodes sends the navigation information, control information, detectors, space stations. These all the nodes information will be sent to the space stations. The relay nodes also stores a forward scientific data. It can be stored and it can be forward the data to the stations. Through this DSON, deep space equipment can transmit data to Earth stations by multiple hoop manner. In multiple hoop manner, we will consume much energy. For those only, we are prefer uh, unidirectional. Here we can see this structure of a DSON, deep space optical network. In this, we are seeing one Mars, Earth, and Moon. We have so many satellites in the space. The connection between the one satellite and another satellite will be small and large points between those. If we have any large communication between them, the data rate will be slow and some of the noise will be added in those things through wire. If we are going to use optical wireless communication, we can't get that disturbances, and we can communicate with large points and small points easily, and we can transmit data. Bitrate will be bit better to that wireless wire communication. This topology can be regarded a channel is in the certain segments. Here we don't use any channels regarding all those things. Uh, this is the flow chart. The ant colony algorithm is purely based on real ant colonies. The how they are behaving, how they search the food through surroundings, how they get trial and error like methods they will use. Artificially, we are going to use those theory through the iterations. If the ant will be such a food means the all every ant will be goes there and they will search for shortest way to get that food. Like that only our the algorithm also makes like that only. First we start that searching for the data and initialize the parameters. How the parameters will be there, the data will be collect. and those and then we create a solution for that data or parameters, and then we update the phenomena trials, and we will for every iteration the solution will be changed. If the solution will be changed up to the maximum level, or if how much we are expecting from that solution, or the path or speed will be we are reaching to that, the solution will be comes to the end. This is the iteration we are going to use. Here we can see this the what we discussed above in flowchart. The 10 steps will be displayed here. First we are going to initializing how we are searching that datas and nodes. Those will be we are first we are initially we are sending so many ants to search for the datas through source node. All those things will be in this 10 steps only we are going to introduce you. The applications and colony algorithm can be used to optimize the network topology for wireless optical communication network. And wireless optical network of algorithm can help identifying the best path for the data transmission between network nodes. Wireless optical communication networks, the algorithm can help allocate resources such as bandwidth, power, and spectrum to different network nodes. Wireless optical network algorithm can help identifying potential security threats and recommended approaches security means to military them also. Here's the result. In this result, we are going to discuss about two methods. One is the traditional method, which the ants will be doing, and another one is the root algorithm and colony algorithm will be the different. Here we can see in this graph two graphs is there. Black one is the traditional ant colony algorithm, and red one is the routing algorithm based on ant colony algorithm. In this the much difference between these both algorithms, because one is the traditional one which we are going to analyze, or it is a real time thing. In this route it is an artificial which are going to generate from node to node and everything will be happen. um, if we want if we are going to connect node 1 to node 6, the spectrum simulation will be up to 25 times. That was the best point to reach, or 10 only we can take. Here the nodes will be displaying as a dot, and in this second we are in this second graph we observe that energy, how the energy is consumption having. In traditional and colony algorithm, consumption of energy will be very much low. In artificial it much increased by up to 15%, 50%. But in every in other methods the energy of consumption will be more, and we can't provide that much energy in the space. Conclusion: we make full use of existing unidirectional to realize the searching for optical path DNOS because of power consumption and traffic between the data flow and all. Similar results shown to algorithm efficiency. Unidirectional links are valuable for energy consumption. Combined with the characteristics of deep space laser communication, we proposed a DSON structure based on this multiple hop transmission for DSON. In addition, we proposed a effective algorithm called RAACA. It is nothing but a root algorithm through and colony algorithm. These are all work by unidirectional link. These are the references which I referred from IEEE. Thank you guys.